what brings you to this meetup? Are you just promoting your product?
I just want to check out the local ecosystem, meet new people, discover the lab. So super excited.
What about you? Same network and take a tour.
Yeah.
Make your way over here. So welcome. As you guys just heard, my name is Gabby. I'm part of the shop staff team here. I spend most of my time in the 3D print shop, kind of our DigiFab spot, and then also help out with the rest of our shop staff. This is Michael. Michael is one of our shop leads as well. He's going to give a quick demo on this new ABB robot we had. You guys are going to hear a lot about technology centers, Autodesk technology centers tonight. This is one of them, and we're part of a big network. So we have another one in Boston, one in Toronto. There's space in Birmingham, England, as well as Portland. This is actually a machine that was in our Boston Technology Center for a while. I just got over here, and we've kind of been learning the ropes and trying to wrestle with it and make it do what we want. But yeah, so I'm going to let Michael take it from here.
Yeah, this is our newest acquisition. It's a collaborative robot. It was designed to be collaborative. What that means is it's kind of safe for people to occupy the same space as it. What makes it collaborative is it has a really low payload, just a pound in each gripper. It has kind of this soft padding to protect you from like pinch points. It can sense when, if you just kind of touch it, it can sense that difference in joint load and will just stop. What I'm doing with it right now is I'm using software that one of our researchers in Boston has developed called Machina. It's kind of a way to manage communication between this robot or different kind of robots and softwares like Processing or Grasshopper, or in this case, MATLAB. And what I'm doing with it is just having it try to track a kind of a green ball. Just from like my webcam. So I'm just helping this developer. This robot is kind of unique for having 2 arms and also 7 degrees of freedom in each arm. So I'm helping our developer get this robot working with his software. There's kind of other tools that we're developing, kind of open source that we're developing here. One is with Unity. We're bringing in like a library of different robots inside of Unity. And one is with Maya. It's called Mimic. It's a way to kind of control these robots from within Mimic. It's good for kind of complex like pans and zooms with video cameras and special effects.
Thanks, Michael.
Yeah, sure.
So this space that we're in right now is called the Simulation Studio. It's kind of where the office flows and then becomes almost a shop. So we're starting to fill this space out with more tools like this collaborative robot. This is our electronics lab in the back here. So it's kind of like, it's got all of our Arduinos, some soldering equipment, and then we also have like a flex space here. So there's this right in this corner. The reason why it's called simulation is because this is kind of a little bit of a VR lab. So we have a couple other VR labs in the Pier, and this is the one that like anyone of our residents can just kind of come and hop on and do whatever they want. It doesn't have a specific project dedicated to this space. And then from that direction is all office space. So that's all of Autodesk research teams, a lot of people that are working on generative design and kind of machinability of generative design parts right now is a big thing, and then also our residency program. So with that, I think I see the first tour heading into the robotics lab. So we're going to head onto this, our bridge. This bridge is over our CNC lab. So we're going to be looking down, looking at the different machines, and there's a couple projects that are on the bridge that we're going to talk about. There's a ton of people here. It's a massive tour. So just be respectful for everyone with space and whatnot. And if you didn't hear, food goes on the table, food and drinks. We're not allowed in the workshop. And with that said, let's head on to the workshop. Sorry, I got a passion right here. Okay. So can you actually close that door then? And just hang out there.
Yeah, I'm sure.
Sorry.
Start doing stuff and change the world. Like, I mean, not change the world, like.
Boom.
That's probably right.
It's kind of cutting them.
So, everyone in the beach shop right now, on the left side of the bridge, is actually going on right now. Usually any residents or any Autodesk employees that are in the workshop are actually running their own machines. They're doing their own projects. So we're not really a job shop, but more of a shop that we kind of teach our users how to do the projects themselves. So this machine is in production mode right now. It's running a part that's been proven out already, so that part has been run before. It's actually a generative design part. So you can begin to see it emerging from the foam over there. It's kind of one of 6 pieces that are going to fit together. And we're machining out of foam first to prove out the geometry before we go to aluminum. So this is a DMS 5-axis router. This is where we do most of our kind of wood, plastic work. And then on the right side, you're going to see our CNC HOS and mill. So this is a 3-axis HOS. And over there in the very far corner is a Datron mill. So that's like for really high precision, tiny bits. It has a really cool pneumatic bed that holds your parts to the bed. And then on the right side of the bridge over here, you're going to see our water jet. So this is basically shoots water and abrasive out at 50,000 psi. You can cut through most things. It does have a 5-axis head, so you can cut some really like fillets, interior parts, and whatnot. This is a Matsura. So this is a 5-axis mill. It's a Japanese machine. It's kind of the newest machine, or one of the newest machines in our workshop. This used to be a Moriseki here, and it's a really popular tool. And on the right side, if you look right down below us, you're going to notice all these wires that are attached to this bridge itself. So there's actually a project going on and sensing the vibrations that are going on the bridge, collecting that data so that it can then track kind of like what's moving across right now. Is it a dog? Is it a person? Is it 10 people? And this is part of a bridge project that's happening in Amsterdam, MX3D. So that's actually basically, imagine robot arms printing their own track across the river and then basically printing the bridge out of metal, and they want to use this sensor system embedded into that to track that bridge use over time. So then also the ribs that were 3D printed that hold the railing up, those are all generative design parts in some of our early generative design software. And then on the left side, you see this giant fan over here displayed. So this is half finished machine on the wall, and this is actually done in our other technology center in Birmingham, England. So they really specialize in kind of advanced consulting for like really high profile Autodesk clients trying to solve really tough problems. It's a newer facility and it's pretty badass if you guys want to check it out online. With that said, does anyone have any questions related to our CNC shop or anything that you've seen so far?
What's a high profile client?
Like NASA or GM or anyone that either we sell a ton of software to or we're really excited about their project and want to be a part of it. Or someone that's a really good test case for new technology that we're developing, like generative design. So generative design, this is using basically algorithms to design a part. So oftentimes, like so many things can be called generative design. If you model in Rhino, there's tons of Grasshopper scripts that are generative design. Autodesk generative design is kind of a very specific part of generative design, and that's in the sense that you're going to give it the constraints of what your part, so like let's say a bracket that goes on a wall. So your bracket's going to need to have support a certain amount of weight. It's going to need to be able to connect to the wall where a couple of screws go through to mount it. So you're going to model just those screws, tell it what material you're going to manufacture it, how you're going to manufacture it, and it's going to give you like 100 designs different design directions to go into. And then you can say, oh, I really like this one, and then it's going to give you 100 more of that. So it's able to kind of like speed up the amount of different options you're looking at. And when we first developed Autodesk Generative Design, it was like, okay, cool, we can make all these crazy geometries that can only be made using 3D printing, but that's not how the kind of manufacturing industry is set up. That might not be the material you want to use. And so now they're looking at how do we put in machinability into our algorithms so that it's thinking, oh, we're going to use a CNC Haas mill. It only has 3 axes, so I can't just put whatever geometry I want in there. I need to actually leave room for my bits to come in, make sure that I'm going to be able to flip it and it's not a 5-axis part, putting that into it, as well as questions about do I actually want a part that looks like that? So sometimes generative design it's really beautiful, it's natural, it's organic, but it's like, do you want all your parts to look like that? Not really. Like, also sometimes you want it to have straight lines. You want it to have a different design aesthetic, and so how do you factor that into the algorithm as well? So
I have a question. What are the biggest challenges you face on a day-to-day basis here?
In the workshop as a shop staff member?
Yeah.
It's that's a great question. I think so each person is going to have a unique project, and so they're going to come to me and they're going to try to, I want to do this thing, and it's kind of like figuring out how to manage like empowering them so that they can do it themselves versus like what are their expectations, like how do I manage those expectations, like what are they trying to get out of it, is that possible, is that within my job description, or is that too much? So it's kind of managing all of these different factors to like empower our users, but in a way that is in line with our business goals.
And what's the craziest thing you've seen built here?
The craziest?
Yeah.
Oh man, I've been here for 5 years and there's been so much stuff. If the most recent thing is a really amazing generative design lander. It's a concept piece, but it was like this massive metal lander. It just was at AU and is on the internet, and is for going to some moon. But it's basically incredible because normally if you wanted to 3D print out a metal, something that size, you would have to basically weld all these different sections together, and they actually use sand casting to be able to like blow the build envelope so much larger to get an actual metal part. And sand casting is really cool because it actually is rated for the aerospace industry. And so that's something that's like been really, really recent. It was just announced a couple of weeks ago. But there's been lots of other amazing projects too.
Oh, thank you.
So sorry, I couldn't talk to everyone. There's lots of people here. Waiting for a shot. So thank you.
Yeah. So they're kind of our counterparts. So they're automating. Thank you.
It's selling a product for like $20.
Oh, so sorry. I'm so sorry.
So we,
So shit. Printer, 3D printer. 3D printers.
We're gonna make our way over here.
This stuff's insane.
So details.
So normally the tour stops over here, and these are like most simple parts.
Making that is insane.
We don't have any metal. The reason why we don't is because they're not that
I guess we're not supposed to do that.
That's that.
I don't know how you make that.
Probably would look at SLA.
Yeah, like it's
Still making that.
so like pretty crazy.
It's
It's the future.
Yeah, I know. It's cool.
So this is the machine learning lab. There isn't much to see here, but we're going to go into the robotics lab here. You're going to run into a bunch of desks. We're going to walk all the way to them and then down the stairs. Down the stairs. Next aerial down the stairs.
Yeah.
Officer.
Got that.
It has a name. What's going on?
Oh yeah, that's like So I'm gonna have everyone keep moving down because there's so many people in here.
It's a really big arm.
Biggest one I've ever seen.
Yes. I'll be downstairs in a second. Let's catch up in the networking section. Keep on coming. So you can see a lot of these desks were actually made by the designers. We had a bunch of plywood laying around. That's why there's plywood everywhere. black arms can work together here. So sometimes one might have a camera, another one might have like a 3D printed spaceship that they're filming something for Ireland. Other times you have this one over here. These are two collaborative arms as well. This is one of my favorite projects, this Lego project. It's teaching robots how to build with Lego. So that's actually pretty challenging to figure out how the gripper is going to grab each different part and then assemble it together. And so this team is actually working on not only teaching the Legos here, but also in a digital twin in a software. It can learn in the digital space, and then once it's doing pretty well, it can upload it and then start having to learn in the physical space here. So we're going to go downstairs and point out this R2 unit. This big orange robot over here. So the team that developed the plugin for Maya that allows you to control robots, Mimic, use that machine to weld 3D print. So over there's like tentacle arms. There's this like a flower sculpture over here. Those are actually 3D printed with that robot arm and a welding attachment. Their style 3D, they call it shrimp. Supervised high-rate metal 3D printing. And there's a bunch of sample parts over here on this side. And this is the robot lab. So there's, oh yeah, one last thing you'll notice is there's all of these cameras around here. So these are all mocap and different things to capture the robot in space and then make sure that that's, you know, actually they use that for the digital twin in Maya. And this team does a lot of specialty projects for Autodesk. So they often do a project for AU and kind of prototype it in this room and then bring it over there and replicate it there. We're going to head out this door right here and maybe we'll go down to the front of the building. Sorry, we ran out of time.
Oh.
Grab your head.
Maybe that one.
She said they don't have any metal casting 3D printers because of
They were talking about their shrimp thing, right? I guess that's not metal.
Well,